Let us start with the positive clamper. Let me share the presentation. Fine. So what we have in a positive clamper compared to a negative clamper, the direction of the diode is changed. Again, we assume that my input voltages are Vin with a peak at plus Vm on the positive side, minus Vm on the negative side. As what was the case in a negative clamper, same would be the case here. When the diode is on, it is in a forward bias state, it would act as a closed switch. This would be a short circuit. The voltage across parallel branches would always remain same, and hence the output voltage would be zero. And when the diode is off, this is out of picture. So now my loop is going to be this. So what would be my output voltage? My output voltage would be equal to Vin minus Vc. So this consideration remains same whether it is a negative clamper or a positive clamper. So when the diode is on, my output voltage is zero. When diode is off, my output voltage would be Vin minus Vc. Let us start with the positive half cycle. Let us assume initially that the capacitor is uncharged, that is Vc is equal to 0. During the positive half cycle, this terminal would become positive, this terminal would become negative. So if you try to understand, capacitor is initially uncharged, so this voltages are 0. Negative terminal of diode is connected with positive. Positive terminal of diode is connected with negative. Diode is basically reverse biased. As the diode is reverse biased, output voltage would be equal to Vin minus Vc. Vc is currently 0, so the output voltage would be equal to Vn. This is what you get here. Follow my cursor. The part of the waveform between time t equal to 0 to this blue line, this is my positive half cycle. So this positive half cycle is reproduced here exactly in the same way on the output side with a peak at Vn, right? Because the diode is reverse biased, the current would flow in this loop. Again, considering the the value of the resistance RL to be very large, the time constant is going to be very large. So the charging of the capacitor would be very, very slow, and hence we can assume that capacitor would remain at 0 volts only. There would not be any charging of capacitor that would happen. So we can approximate, or we can say that because there is very slow charging, the capacitor would not charge and Vc would still remain equal to 0. Right? Let us go to the negative half cycle. What would happen in the negative half cycle? In the negative half cycle, that is this part of the input waveform, what would be the case? In the negative half cycle, this terminal would become equal to negative, this terminal would become equal to positive. Now this polarity of the input voltage would make the diode to be reverse biased. Sorry. This polarity of the input voltage, this terminal positive, so P is connected with positive, N is connected to negative, the voltage across the capacitor is still 0. This would make diode to come in forward bias state. So in the negative half cycle, from 0 to minus Vm, that is till the time input voltage is larger than minus Vm, the diode would remain in a forward bias state, and hence the output voltage would become equal to 0. This is what is indicated here. The output voltage would come out to be equal to 0. The current would flow. The current would flow in this loop. The current would flow like this. Now you can understand that as the current flows like this terminal of the capacitor would become positively charged and this would become negatively charged. And as the loop is having almost zero resistance, considering diode to be ideal, the time constant would be 0. So the charging of the capacitor would be immediate. So as the input voltage increase, or I would say input voltage changes from 0 to minus Vm, input voltage changes from 0 to minus Vm, the voltage across the capacitor would also become from 0 to minus Vm. I say minus Vm is because, see, the initial polarity of the capacitor that we have assumed is plus and minus. But here the voltages, the charging of the capacitor is such that this terminal of the capacitor becomes positive and this becomes negative. So Vc is equal to minus Vm. So the capacitor would charge up to minus Vm. Now once the capacitor charges up to minus Vm, after this point, the input voltage starts getting higher than minus Vm. In that case, diode would again come in a reverse bias state, right? So as input starts increasing from minus Vm, diode get reverse bias. Diode get reverse bias, output voltage would become equal to Vin minus Vc. So now Vin minus Vc, Vc is equal to minus Vm. So input voltage would become, sorry, output voltage would become input voltage plus Vm. Mind well, how do we get this plus here? Because Vc, the polarity of Vc that we have assumed here and the way in which that capacitor charges gives us Vc is equal to minus Vm. So if I put minus Vm here, it would be in Vi, input voltage plus Vm. So what does this mean? This means that at the end of the negative half cycle, when the voltage become equal to zero, when the voltage become input voltage becomes equal to zero, the output voltage would become equal to Vm. So if we consider this negative half cycle, in negative half cycle for the half part of it, the output voltage would be zero because diode is in forward bias, capacitor would charge, and after that the output voltage is equal to input voltage plus Vm. Again, we make the same assumption that RL is very large and hence there would not be any discharging of capacitor that would take place, and capacitor would hold the value of Vc equal to minus Vn. Right now, after this negative half cycle, if you consider the next positive half cycle, then in the next positive half cycle also diode would remain in the reverse bias state. Diode remains in the reverse bias state. Output would be equal to Vi plus Vn. So this positive half cycle appears here. At 0 volt I would get Vm, at Vm I would get 2 Vm. So now if you see that the whole on the output side, the whole input signal has been shifted to the level of Vm. Thus, once the capacitor is charged to minus Vm, diode will always remain in a reverse bias state and output voltage would be equal to input voltage plus Vm. Thus, the input voltage is pulled up by the value of Vm. As the input voltage is pulled up by up on the positive side by a DC voltage of Vm, we consider this to be a positive clamper, right? So in the negative clamper, the voltages where the DC voltage that were added pulls down the input voltage, whereas in positive clamper it basically pulls up, right? So this is a positive clamper. Earlier example that we have discussed was negative clamper. Now let us try to take one more example, which is clamper circuit with bias voltage. Let us try to consider this circuit. Here you can actually take a pose and you can try to calculate what would be the output because of this. Let me give you the primary consideration. What we have done here, if you see the condition of the diode, then this condition of the diode tells that this is something similar to a positive clamper. But now, along with this diode, I do have a battery, I do have a DC source with this particular polarity. Let us say that the DC source is equal to Vb, and here we assume that this Vb is less than Vm. What is Vm? Vm is my peak input voltage, right? So, and we are supposed to find the output voltage. We should keep, when we are analyzing this, we should keep in mind that this is basically a positive clamper. Now what would be the basic difference? The basic difference would be now when the diode is on, what would be the output voltage? The output voltage would be equal to minus Vb, because in that case when the diode is on, this acts as a closed switch, the voltage at this branch is minus Vb, so V0 would be equal to minus Vb. And when the diode is off, the voltages would be equal to Vin minus Vc. Another thing, that when the diode is on, the capacitor would charge. Now, to what value would the capacitor charge? Initially, it was charging to minus Vm, but now it cannot charge up to minus Vm because this Vb is coming into picture. So the charging of the capacitor would be equal to Vm minus Vb, right? So if you want, you can take a pause here and you can try to solve this, and then you can again play the video and try to match your answer. Fine. I'm sure you would have been able to put some, you would have been able to get some insight into this question. Let us try to see what can be the basic considerations. So as per the circuit configuration, this is basically a positive clamper. Because of the presence of bias voltage Vb, what are the changes? The capacitor would now not charge to Vm but Vm minus Vb. And mind well, because it is a positive clamper, the current is going to flow in this direction. So this terminal of the capacitor is going to be positive, this is going to be negative, and hence we would call it to be minus Vm minus Vb. And this would happen in the negative half cycle. In the positive half cycle, the output would get repeated. When the diode is on, that is forward bias, it acts as a closed switch. Output voltage would be equal to minus Vb. When the diode is off, it acts as an open switch. Output voltage would be equal to Vi minus Vc. Now, what is your Vc? Vc is minus Vm minus of Vm minus Vb. So you would get input voltage plus Vm minus Vb, right? Thus, the output voltage would basically look something like this. That is, when the input voltage would have a peak of Vm, input voltage would have a peak of Vm. If I substitute Vm here, so I would have Vm plus Vm minus Vb. So my peak would be shifted at 2 Vm minus Vb. My peak would be shifted at 2 Vm minus Vb. And during the negative peak of the input voltage minus Vm, so if I put minus Vm here, so minus Vm plus Vm minus Vb, so this would be equal to minus Vb. So the whole signal is shifted. The whole signal is shifted. But now, because of this presence of bias voltage, the shifting is not exactly equal to Vm, but it is equal to Vm minus Vb. So using the bias voltage, you can actually shift it by any particular level that you wish. In positive and negative unbiased clampers, the shifting was by the level of Vm only. But now if we use this biasing voltage, I can shift it at any level, right? So this is basically the use of introducing a voltage source in the clamper circuit. Thus, summarizing, as the waveform shifts towards positive side and as the circuit is using bias voltage, the circuit can be said to be a positive biased clamper. Let us try to take one more example. Looking at this example, you would immediately realize that this is basically a negative clamper. Why? Because of the direction of the diode like this. And it is basically a biased clamper because of the presence of voltage source. Again, I would request you to pause the video here and try to analyze this circuit, identifying what would be the output voltage. You may pause the video here. I'm sure you would have been able to get some insight into this, right? Let us try to summarize this. The circuit configuration is basically the configuration of a negative clamper circuit. Because of the presence of Vb, what are the changes that we expect? The changes that we expect is that now the capacitor would not charge to Vm, but because of this polarity, it would be Vm plus Vb. Understand this, that the charging of the capacitor would be in a positive half cycle. So in the positive half cycle, this terminal is positive, this terminal is negative. So this negative and this positive basically are supportive. So what is the net voltage which is available across the capacitor? It is input plus Vb. So what is the maximum value of input? Vm. In addition to that, I have a DC source of Vb. So Vm plus Vb would be the total charging of the capacitor. Right? I'm sure you are able to get this. When the diode is in on condition, output voltage would be equal to minus VB. Why? Because you have minus VB here. The polarity of the source is such that here you have negative, downside you have positive. Similarly, when the diode is off, that is reverse bias, the output voltage would be equal to Vin minus Vc. Now what is Vc? What is the voltage across capacitor? It is Vm plus Vb. So the output voltage would be input voltage minus Vm plus Vb. So if you try to sketch the output waveform, when the input voltage is 0, when the input voltage is 0, your voltages are minus Vm plus Vp. When the input voltage has a peak of Vm, so you substitute Vm here, then the voltage would be at minus Vp. So Vm would get cancelled. What you would get would be minus Vp. Similarly, when the input voltage has a negative peak at minus Vm, you substitute minus Vm here. So minus Vm minus Vm minus Vb. So the value would be at minus Vm minus 2 Vm, sorry, minus 2 Vm minus Vb. So you can understand that the whole signal has been shifted down, not necessarily by the value Vm as what happens in unbiased clampers. Here the shifting is by any arbitrary value depending upon what you select the voltage Vb to be. Thus, as the waveform shifts uh, towards positive side and the circuit is using a bias voltage, we would say that this is basically a negative biased clamper, right? Some of the examples are given as a part of your assignment. In light of the examples that we have discussed, you can try to solve those examples, and I am sure you would be able to get this, right? Thank you for joining us on this online session. We would meet with another online session next time. Thank you.